Ladies and gentlemen, welcome to SQL Server Performance Monitoring and Tuning webcast brought to you by SQLWorkshops.com. These webcasts are equally designed for developers and DBAs. This is our third webcast. In this webcast, we will look at CPU, memory, and disk-related query tuning techniques. We will talk about disk seconds per read, the disk latency, and average disk queue length. We will talk about why sometimes it is not bad to have high disk seconds per read, the disk latency, and high average disk queue length. Let me show you a preview of what is coming up and how a developer can help make the query execute faster. Let's execute our first query, this store procedure. While the store procedure is executing, we will analyze the performance monitor counters. Let's start this query and let's collect the performance monitor counters. Let's freeze the display and let's look at average disk read queue length for drive N. There you see it is around 0.5, 0.498 on drive N, and on drive M it's also around 0.5. When we add together, the average queue length is slightly less than 1. My database, test22, is located over two drives, N and M, the data files. Let's look at SPHelp file on test22. There you see drive M as one data file and drive N as the other data file. Both are same in size. Let's look at the counters further. There you see average disk seconds per read, the disk latency, is 8 milliseconds on drive N and 9 milliseconds on drive M. Average is around 8.5 milliseconds over these two drives. Disk read bytes per second, the disk throughput, is around 500 kilobytes on drive N and around 500 kilobytes on drive M. Altogether, both drives are making around 1 megabyte per second. This is random I/O. When you look at the disk bytes per read, there you will see the queries are doing 8 kilobyte reads. They are not doing extent at a time. They are doing page at a time. They are random seeks over clustered index. Let's also look at disk reads per second. There you see 58 reads over drive N and 57 reads over drive M. So it's around between 50 and 60. Let's look at how long the query executed. The query took 18 seconds to complete. Let's execute a second query. This store procedure, instead of test_pf1 with parameter 1000, we will execute test_pf2 with parameter 1000. Both store procedures are the same. When you do a SPHelp text, there you will see the content of the store procedure is the same. If you want to take a longer look, pause the webcast, take a look, and continue. Let's execute this store procedure. While this store procedure is executing, we will collect the performance monitor counters. Let's execute. Let's collect the counter values, give it some time, let's freeze it. Let's look at the average disk read queue length. It is around 4.4. It is no more 0.5. It's 4.4 on drive N and 4.7 on drive M. So they are between 9 to 10. If you add the disk queue length over two drives, they are between 9 and 10. If we look at the average disk seconds per read, this is the latency, it's around 48 milliseconds. It's no more 8 milliseconds or 9 milliseconds. It's 48 milliseconds on drive N and 50 milliseconds on drive M. If you look at disk read bytes per second, this is the throughput. It's around 800 kilobytes on drive N and 800 kilobytes on drive M. So altogether they are doing around 1.5 to 1.6 megabytes per second. When you look at disk reads per second, it is no more 58. It's 93 on drive N and 94 on drive M. Let's look at how long this query took to complete. It took 11 seconds to complete. It did not take 18 seconds. This query took 11 seconds to complete. The second query is nearly 2 times faster because it uses all the 2 disks I have in parallel by maintaining outstanding IOs on both disks. On the other hand, the first query also uses 2 disks, but not in parallel, 1 disk at a time, maintaining the queue length 1 across both disks. Let's analyze the execution plan. There you see a nested loop join over table temp and table tab 71. Let's look at the cost. The estimated subtree cost is 0.085. Let's look at our first query. Let's look at the execution plan. There you see again a nested loop join over table temp and tab 71. The estimated subtree cost is 0.082. The cost is nearly the same. If you are running a third-party monitoring software, all the disk lights will be green when the first query executes because the disk seconds per read, the disk latency is low at 8 or 9 milliseconds. Looking at the wait stats, page IO latch waits, which we will analyze later in this webcast, almost everyone will say that the query is disk bound. They will say you have to reduce the IOs or buy faster disks. But this query has got the best index. The query is using our clustered index. This is not an indexing issue. Let's say this is one of the CEO reports or the billing job. These jobs have to do what they have to do. They have to read lots of data. I have seen this problem occur in OLTP systems as well. This can affect queries that read as low as 50 or 100 pages, which many OLTP queries do. Think about it. Let's say you got 4 disks in your RAID 1.0 configuration or 20 spindles for your SAN volume. Is it good to use 1 disk at a time, 1 outstanding IO at a time, keeping the average disk queue length to 1, or is it good to flood these disks with many IO requests, keeping the outstanding IOs very high, keeping the average disk queue length very high on all these disks, spindles, in other words, using all these disks in parallel? Of course, you have invested in this expensive hardware. You got to use them efficiently. If you got 20 spindles, the query could run 20 times faster. When you keep the disk queue length at 1, the query will use 1 disk at a time. The query will be slow. The disk throughput will be very low. In our case, nearly 500 kilobytes per second. The disk latency, the disk seconds per read will be very good. In our case, 8 to 9 milliseconds. But this does not help our query. When you keep your disk queue length high, all disks will fetch data in parallel. This will lead to better throughput. This is good for the query, for the CEO report or the billing job to complete faster, or even for simple OLTP queries that joins orders with order details. In this webcast, we will show you how to flood the disks with IOs. But when the disk queue length is high, let's say at 10 like ours, and if you have got 2 disks, the disk seconds per read, the disk latency will be high. This is because SQL Server does not just queue up 2 IOs. Because you have 2 disks, it queues up more. This is actually good as these pages are randomly distributed across these 2 disks. So higher disk queue length will make sure each disk is in fact busy. In our case, the disk seconds per read, the latency is very high at 50 milliseconds because some IOs will simply have to wait. They will increase the latency, the disk seconds per read. This is common with SAN. Your hardware might support a maximum of 32 outstanding IOs, but SQL Server might queue up 100 IOs. The rest, 68 IOs, will wait in the operating system queue, increasing the disk seconds per read, the latency. Let me give you an example. The first query will wait with page IO latch wait type. In fact, both queries will wait with page IO latch wait type, but first query will wait longer on page IO latch waits because it is issuing 1 IO at a time, executing longer. We will analyze page IO latch waits later in the webcast. Let's say our DBA Dale calls the SAN administrator. The SAN administrator Steve arrives at DBA Dale's office. He says to our Dale, "Your manager told me that you wanted to talk to me." Don't yet think the SAN administrator Steve has got an attitude. He has a reason for that, and you will understand it soon. The DBA Dale says, "Yes, the query is always waiting on disk. Page IO latch waits. The disk is the bottleneck. Can you check what is going on?" The SAN administrator Steve says, "Look, your loon can handle 200 megabytes per second. I monitored the SAN traffic before I left my office. You guys are way underutilizing the capacity. You are doing 2 megabytes per second. You got a problem in your application." Well, the DBA Dale in fact looked at the performance monitor counters before. The disk queue length was 1, 8 kilobyte IOs, disk seconds per read, the disk latency was low, but the throughput was not high. The SAN administrator Steve is correct. Dale knows we are not stressing the disk, but he doesn't know what to do, and he thought maybe the SAN administrator might help. DBA Dale says to the SAN administrator Steve, "Maybe you can check it out again tonight when we run the billing job." This is what I call a typical fly-by communication. They don't connect. They don't understand each other. What the SAN administrator wants to see is the DBA, the SQL server, flooding the disk with IOs, not one at a time, 10 at a time, 100 at a time, so they can exploit the SAN capacity, the bandwidth. But DBAs normally think about lower disk latency, disk seconds per read, and lower disk queue length. For some reason, DBAs don't like high disk latency, disk seconds per read, or high disk queue length. When these numbers go high, so does the color coding, from green to orange and so on, and DBAs don't like anything other than green. When you execute the second query, the SAN administrator Steve will be happy. He will finally see the SAN hardware being used efficiently. That is all spindles fetching data. In this webcast, we will show you how not just to make SAN administrator Steve happy, but get Steve to add more spindles to our loons or volume to make the query run as fast as we want. But when the second query is executing, the disk queue length will be high. In our example, it is between 9 and 10. There will be high disk latency, disk seconds per read. In our case, it is around 50 milliseconds. This is not a problem because our second query completed fast, and this is what we care about, doing around 800 kilobytes per second instead of 500 kilobytes per second. In some cases, not in all cases, in some cases like with our query, you have to ignore the best practice guideline recommendation of having no more than a queue length of 2 per disk or spindle and no more than 10 millisecond disk latency, disk seconds per read. If our CEO report completes fast, if our billing job completes fast, our CEO will be happy. We will get our bonus. We will be happy. No need to worry about high disk latency, disk seconds per read, or high disk queue length. We at SQLWorkshops.com help you identify these issues and help you correct them by rewriting the first query so it always floods the disk with lot of IOs. Our goal is to fully utilize your hardware, your existing hardware, your existing investments. If you are not at the disk bandwidth capacity, if you are not fully utilizing your CPU, but your CEO reports or billing job is still slow, then there is a bottleneck in your software. Could be anywhere, application, SQL server, operating system, firmware. We are talking about advanced tuning, not missing index tuning. For that, you should first use Database Engine Tuning Advisor to figure out missing indexes or helpful indexes. We are going a step further where you have the right index, but things are still slow. In this case, the execution plan for both queries look the same. We at SQLWorkshops.com will not ask you to simply keep buying hardware. We will empower you to fully realize the performance potential of Microsoft SQL Server without increasing your TCO, total cost of ownership. This is just a preview of what is coming up in this webcast. If you manage to watch the webcast 3 in full, and if you developers and DBAs rewrite these queries, these stored procedures, you might hear this on the walkway when you cross over the offices of Oracle colleagues. Don't be surprised if this happens. Hey, look, SQL guys figured out how to use the SAN. What do you mean? They are queuing up more than one IOs. They are exploiting the capacity of the SAN. What does that mean to us? Well, we have to buy our own disks. We can't keep exploiting their disks anymore. In this webcast, we will also talk about how a parallel query can slow down from less than a second to more than 10 seconds, to more than a minute. Let me show you a preview. Let's enable sort warnings. Let's start the profiler. Let's execute this query. This query is fast. Let's see how long this query took. 361 milliseconds. Let's execute it again. This query took 442 milliseconds. The query is taking less than a second. Let's look at the execution plan. There you see the query executed in parallel. Right now, the CPU utilization is nearly 0 or 1%. Let's execute this query in a different session. This query reads the data from the cache. Since we set max degree of parallelism to 1, this query will spin indefinitely, because we have while 1 equal to 1, will spin one of the CPU indefinitely to 100%. Let's execute the query. Let's monitor the CPU. There you see our fourth CPU is at 100%, and the average CPU utilization is around 25-26%. Now let's execute the query that executed fast in the past. This query will take a long time. This is not related to memory issue that we discussed in the last webcast. There you will see no sort warnings. This is not related to disk issue. This is related to CPU scheduling issue. There you see the query took 14 seconds. We will analyze this parallel query issue and find a solution. Watch this webcast in full. We will also talk about hash join spilling to TempDB, hash recursion, hash bailout. We will analyze sleep task wait type and IO completion wait type in detail. We will also demonstrate why SP recompile statement can be dangerous, can bring down your application to a standstill. If you have not seen our previous webcasts, we recommend you to download the webcast from SQLWorkshops.com and watch it first. My name is Ramesh Meyapan. I will be presenting this webcast. Like before, I will recall some conversation with Mr. JLR, which will be in a discussion format. When I deliver a workshop or present a session in a user group meeting or conference, I strictly deliver technical content. For example, you can see that in my SQL Bits session recordings. But in these free webcasts, we include some side discussions that are not technical. This is our business decision. Using stored procedures or other planned caching mechanism is not recommended for memory allocating queries. Let me tell you, this is a common mistake developers make. Like, one should not drink and drive. I mean consume alcohol and drive. Developers should not combine memory allocating queries and stored procedures together. It is dangerous. Your SLA, service level agreement, might be in jeopardy. This is not limited to stored procedures. It also applies to any planned caching mechanisms, like using SP execute SQL, prepared statement using ADO.NET or OLEDB based executions. Common memory allocating queries are that perform sort or do hash match operations like hash join or hash aggregation or hash union. Let's see an example. Here is a query that does a join. This example is to demonstrate hash join memory allocation. So you have to choose a similar query where the optimizer chooses a hash join to understand the issue. We are giving parameters January 1st, 2005 and 28th February 2005 with max DOP1. Let's execute this query. Let's see how long the query took to execute. 671 milliseconds. Let's execute the query again. Let's look at the execution time, 668 milliseconds. Let's look at the execution plan. There we see clustered index seek, and a hash match. Let's move the cursor on top of the hash match operator. There you see estimated number of rows 83,000, actual number of rows 83,000. Let's include hash warnings in the profiler so we know when there is a hash recursion or hash bailout, meaning hash join spilling to TempDB. Let's start the profiler. Let's execute our query again. Let's look at the profiler if there was a hash warning. No, there was no hash warning. Let's execute our query again with a different set of parameters. January 1st, 2005 and 30th June 2005. Instead of 2 months, we are processing 6 months of data. Let's execute this query and let's see how long this query took. This query took around 2 seconds. Let's execute the query again. This query seems to scale well. Let's see, around 2 seconds. Let's look at the execution plan. Similar execution plan, clustered index seek, and when I move the cursor on top of the hash match operator, there you see 259,000 rows estimation, 259,000 rows actual. Let's look if there were any hash warnings. There were no hash warnings. Let's execute the same query using a store procedure. Let's create a store procedure that accepts 2 parameters, start date and end date. Let's call the store procedure with January 1st, 2005 and 28th February 2005. Let's execute this query. The performance is similar to what we saw before, 658 milliseconds. Let's look at the execution plan, clustered index seek, hash match. Let's execute again. 655 milliseconds, clustered index seek, hash match. Let's look at the profiler if there were any hash warnings. No. Let's execute the query with a different set of parameters. January 1st, 2005 and 30th June 2005. Let's execute the query. The query used to complete in 2 seconds when we did not use a store procedure. Now it's taking a long time. Let's look at the profiler if there are hash warnings. Yes, there are hash warnings. Recursion. This shows the hash join spilled to TempDB. Let's look at the query. The query took 17 seconds to complete. Let's look at the execution plan. The query took 17 seconds to complete. Let's look at the execution plan. Similar execution plan because the plan is cached. When you use store procedure or any plan caching mechanism, when you execute the query the first time, the plan is cached based on the first set of execution parameters. Let's move the cursor on top of the hash match operator. There you see the estimated number of rows is 83,000. Actual number of rows is 259,000. So if some user calls a store procedure that does a hash join to process less number of rows, the plan will be cached. Later on, when people reuse the plan to process large number of rows, they will pay a penalty because they will use the same amount of memory that was estimated for the first set of parameters. I know some of you are thinking about using plan guides. Let me tell you, you cannot use plan guides to fix this problem. Plan guides will not help you here. We will discuss plan guides later in this webcast. Mr. JLR asked me to introduce myself. I told him I am an independent SQL Server consultant and trainer. He asked me, does that mean I do not consult on Oracle? I said yes, only SQL Server. He asked me if I am affiliated with any third-party software or hardware companies. I told him no, I am an independent consultant with reducing TCO, total cost of ownership, as my primary goal. He asked me, how about the operating systems? Do I have a preference? I told him, I have not got much choice here. I can work with Windows Server 2003 or Windows Server 2008, anything the customer got. He asked me, how about the internet search providers? Am I independent? Do I use only Bing or Google as well? I told him, I can use both. Then he explained me why he was questioning me. It turns out that I used only Bing in my last webcast. I told Mr. JLR I will use Google this time. Mr. JLR told me he has difficulty spelling my last name. I told him if he executes this query in the Adventure Works database, select contact where first name equal to Ramesh, he will find the spelling to my last name. Let's monitor TempDB activity while we are executing our store procedure test. We are selecting number of reads, bytes read, number of writes, bytes written from virtual file stats for database TempDB file ID 1. There you can see I have one database file for my TempDB database. The file ID is 1. We are going to select from virtual file stats, execute our store procedure, and select from virtual file stats again to see if there is any activity over TempDB. Let's execute the query. The query is fast. The parameter was January 1st, 2005 and 28th February 2005. There was no activity in TempDB. Number of reads and number of writes are the same. Let's execute the same procedure, virtual file stats, our store procedure, virtual file stat with different set of parameters. January 1st, 2005 and 30th June 2005. Let's execute this query. We saw in the past when we executed the query, we had hash recursion. So this query is doing hash join over TempDB, and we will see the activities over TempDB. There you see the amount of writes before and after is not the same, and number of writes before and after is not the same. So this query wrote data into TempDB and read it back. We will take a closer look. Meanwhile, Mr. JLR asked me to discuss the third option to improve his SQL Server knowledge. In the last webcast, we discussed about reading books and attending conferences. I told Mr. JLR the other possibility to develop SQL Server knowledge is to join user groups and learn from other users. Mr. JLR asked me what kind of user group to join since there are many of them. I told him that he should choose a user group that is democratic, where the user group president plans agenda based on user group member needs. Mr. JLR asked me to give examples, and I told him the user group should be run by users for users. Only users understand the other users' need. A business-to-business user group is a no-no. They will sell you stuff like private companies, like profitable businesses. User group should stay non-profit and not contribute to total cost of ownership, TCO increase. The president of user group should be elected by members in a democratic way, and they should not stay as lifetime president. He told me I am asking for too much, and with these criteria, it is difficult to find a user group. I told him I disagree and asked him to show examples. Mr. JLR asked me to visit SQLpass.org website. He asked me to move the cursor on top of About Pass and choose Election 2009. There he asked me to scroll down and click on 2009 slate of candidates. There he asked me to choose one of the candidates. Right click, open link in new tab. There he pointed out under career highlights that this person is a member of this organization's customer advisory board. He said this person is connected to this organization. I told Mr. JLR everybody is connected to some organization. This person is connected to this organization, so what? Mr. JLR pointed out that this person is an editor of this website. He asked me to open this website. So I click on the new tab and I open this website. There he pointed out this website is powered by or sponsored by the same organization. I said, so what? He asked me to look at the next candidate. Right click, open link in new tab. There he pointed out under career highlights that this person is also associated with this website. They are all connected. I told him 2 people are connected, so what? I don't see anything more. He asked me to choose the third candidate. Right click, open link in new tab. There he pointed out this person is from this organization. He told me these two organizations are connected. I said, I don't see that. He asked me to search in the internet. He asked me to put this organization name and this organization name and the word partnership. There he pointed out these two organizations are partners, and the election was taken over by a partnership. I told him this all looks to me like a coincidence. Let's get back to our query. Let's execute our query in a loop while 1 equal to 1 with parameter January 1st, 2005 and 28th February 2005. This is a fast query. Let's execute the query and let's monitor the activity of session 66. Let's look at status and wait type from DM exec requests for session ID 66. There you see status is running, wait type is null. This query is not waiting for anything. It's using CPU. Let's stop this query and let's start the next query with parameter January 1st, 2005 and June 30th, 2005. This is a query that has activity over 10 dB. Let's execute this query. Let's monitor status and wait type. There you see status is suspended, wait type is sleep task. Status is suspended, wait type is sleep task. Many of you are wondering, what is the sleep task wait type? We are going to take a deeper look. This is a level 400 webcast. The next few minutes will be hard. So if you are a manager or borderline technical, you can take this opportunity to grab a cup of coffee. Let's reset wait stats. Let's stop this query. Let's reset wait stats. Let's execute our store procedure, the fast one, and let's measure how much sleep task wait time occurred while this query executed, just like we did in the last webcast. Let's execute this query. There you see the wait time is 0. Let's execute again. You see wait time is 1 second. Wait time is 0. The sleep task wait type is not just for our query. There are some internal SQL Server queries. They also use the sleep task wait type. Let's execute our query that is running slow. Let's reset the wait stats like before. Let's execute our query. Let's find out how much sleep task wait time was there while this query executed. We know this query is taking around 2 seconds CPU time. Let's wait for this query to complete. There we can look at the execution time, 2 seconds, 17 seconds elapsed time. So the query waited nearly 15 seconds. Let's look at the results. There you see the system had 23 seconds of sleep task wait during this period of 17 seconds. Now let's monitor how much internal sleep task waits occur within SQL Server during the 17 seconds. Depending upon the type of components you have installed in SQL Server, the sleep task wait time will differ. Some components will use sleep task wait time, and if you install those components, this number will be different, not same like what I see in my server. There you see the total time is 9 seconds. There it was 23. So if you subtract, there you will find out the amount of sleep time experienced by our query. If you understand this wait type sleep task, you can address the issue. Let's search the books online for sleep task. There is a hit on sysdm OS wait stats. Let's click on this link and look for sleep task. There we see occurs when a task sleeps while waiting for a generic event to occur. Not very useful. Let's search the internet. Let's click on the first link from this website. Open a new tab. Looks like a forum. People are asking questions. Does anyone have a better definition of the SQL Server wait, state, sleep task? Good question. Waiting for something to happen. No, this is not the answer. I am seeing the same wait type sleep task. They are always associated with a process ID that has the status of suspended. The issue that I have is that these processes are still chewing up a lot of CPU and I/O. Typically, this will only last for a short period of time, but it will bring everything to a standstill because it will peg the server. Is there a way to clean up these processes before they cause all the problems? Interesting. Exactly what we want to know, but there are no answers. Typical. When you are searching for some deep technical stuff, you don't find answers. The next link is from Microsoft, MSDN. Let's check it out. Right click, new tab. This is the white paper, Troubleshooting Performance Problems in SQL Server 2005. Let's search for sleep task. There it is. Subtract wait for, sleep, and resource queue from total. They basically ask you to subtract sleep task along with lazy writer sleep, so you don't need to look at them. Look, wait type not in. So they are basically eliminating these wait types. Let's search the Microsoft.com website for links. Site Microsoft.com. There are 276 hits. This is the white paper we already saw, and there are more hits with not in. They are eliminating these wait types, but we want to look at this wait type. So we will say eliminate that contains the not in. Let's search 276. Now we have only 90 hits. Let's look at the first one. Right click, open a new tab. Let's look for our sleep task. Let's look. This is a question answer forum, so people are asking questions, and for most part you can ignore most of these waits. Lazy writer sleep, sleep task, these are recent answers. So basically say eliminate, but not with a not in, instead with a where directly there. Right click the next one, open in new tab. Let's look at this one next. Let's search. Along with other wait types, they club this together. Sleep task, broker task stop. So it's nothing special to our wait type, so there is no special discussion. Let's go to the third hit. Right click, open a new tab. Let's again search for sleep task. There they are saying delete some of the misc types of waits and OLEDB if called for. Like before, they are eliminating all these waits. Let's see what is the context. You need a delta to get anything useful out of it. Here are some SPs that you should get started. They are giving a stored procedure gather wait stats 2005. So they give a stored procedure to gather wait stat 2005, and basically inside they are deleting these wait types from the gathered statistics. Interesting. If you delete them, you don't see them, then you don't need to look at them. Problem solved. See, you are being told time and again sleep task is an internal wait type and you should ignore it during wait stats analysis. Welcome to the real world. Tear open that thick bubble, the best practice bubble, advice from experts bubble, the documentation bubble that you are living in. You will see many surprises in my workshops. Like IO completion wait type with sort, sleep task wait type with hash join means we are waiting for IOs over 10 dB to complete due to non-optimal memory grants, due to spill over 10 dB. I'm actually not disappointed, not happy, at the same time not disappointed, since no one in the internet is telling you to hit the hardware store to buy more disks since you have sleep task wait type. Our goal is, like always, to solve these issues without additional hardware or software by simply rewriting the query. We are TCO, total cost of ownership sensitive people. Let's recompile our store procedure. I know many of you are thinking about SP recompile. SP recompile could be dangerous. Yes, I have seen DBAs who have restarted SQL Server. I mean their production SQL Server instance after using SP recompile. It is dangerous. I will show you an example why you should be careful about using SP recompile before continuing with our hash join query. Let's execute the store procedure with parameter January 1st, 2005 and January 1st, 2005. The query is fast. It takes 0 milliseconds. Now I want to trigger an automatic update statistics for this table orders. So I am going to update order status equal to order status. Order status column is used in our query, our store procedures, and I am going to touch minimum 20% of the rows. So let's update the table and let's do a checkpoint and drop clean buffers. The reason I do drop clean buffers is to move this table out of the data cache. So next time when SQL Server executes the query, part of it, when it automatically updates the statistics, it has to read the data from the disk, and the update statistics will take a long time, like it happens in real world. We will execute the store procedure again. This time the store procedure will take a long time to complete, since the optimizer has to first update the statistics before it can optimize this query to execute it, and the data is not in the cache. Let's say we have our SQL Server DBA. Let's call him Dale, sitting in a corner office by the window with a good view. A corner office with good view, that needs seniority. You know what I mean? Our DBA Dale decides to execute SP recompile on this store procedure. This is not new. Dale has received calls from users in the past complaining that this store procedure is slow at times, unresponsive. And the SP recompile on this store procedure seems to solve the issue for a while. Dale is used to this part of his job. You know, DBAs are very sensitive when it comes to executing SP recompile. Sometimes SP recompile takes a long time to complete. They know that. When they are executing SP recompile, and if that SP recompile takes a long time to complete, they become slightly nervous. The better word to describe this is they become uncomfortable. If you are one of their colleagues, this is not the best time to drop by their office to take them on a coffee break. If you try that, they will say they are in the middle of executing some critical procedure and they will deny your offer even if you are willing to pay for the coffee. Let's execute our store procedure. This time the procedure will take a long time to complete because it has to do the automatic update statistics before SQL Server can create an execution plan. Let's execute the store procedure. Meanwhile, let's say our DBA Dale tries to execute SP recompile test. It will take a long time until the automatic update statistics is complete. Let's cancel the executing query by hitting cancel button, just like DBA Dale cancels it when the SP recompile executes for a long time. Let's look if the query has completed. Yes, it took not less than a second. It took 21 seconds. Let's execute the query again. This time the query is fast because it does not need to do the update statistics again, and the execution time, like before, is 0 milliseconds. Let's say our DBA Dale doesn't give up. He executes the SP recompile and succeeds. It says object test was successfully marked for recompilation. Hereafter, if anyone tries to execute the store procedure, they will wait forever. The reason is because DBA Dale stopped the SP recompile test. Normally, during this time, DBAs will get huge amount of support calls from users complaining the system is at standstill. And some DBAs decide to restart the SQL Server instance. I have seen this happen at real customers. One time, next day, the consultant tells me that they tried to recompile and the SQL Server locked up and they had to restart, and after the restart, all was fine. I asked them if they hit the stop button on the Management Studio when SP recompile was executing. They said yes. No wonder for the lockup. Let's see why the stored procedure test did not complete. You know, when one stops the SP recompile stored procedure, it leaves the transaction open. Within the stored procedure SP recompile, there is a begin and commit. When you stop it in the middle, only begin transaction was executed. The commit was never executed. So when our DBA Dale executes the SP recompile command again, he did that within the already open transaction, locking the stored procedure test with schema modification lock. Let's look at our current tran count. There you will see tran count. Utter tran count is 1. It is not 0. A transaction is open in this Management Studio window. Our session ID is 68. Let's say splog 68. There you see a lock, a schema modification lock on this object. Let's cut this object name and we will find out what is this object. There you will see the object is a procedure named test. So our DBA Dale basically locked the store procedure. So if someone tries to execute the store procedure, there you will see our session 66 is waiting for log on the same object. Unfortunately, our DBA Dale does not know that he is the reason for others waiting. Sometimes in panic, they restart the SQL Server. You can look at the books online, all over the internet. Nowhere it will state that if you stop the store procedure SP recompile, it might leave a transaction open. This is what I meant by saying SP recompile could be dangerous. We at SQLWorkshops.com will not teach you the so-called internals. You can see what we teach. You can feel it, see it, use it. You can call it externals if you want. All we teach is usable in a production server. There is no undocumented stuff you need to be fearful about. This is what I recommend. Find the plan handle for the store procedure, use DBCC free proc cache and give that plan handle as a parameter. This is possible with SQL Server 2008. In SQL Server 2005, DBCC free proc cache does not take plan handle as parameter. In that case, if you have to use SP recompile, then don't stop it while it is executing. If you do have to stop it in the middle, then immediately roll back. Mr. JLR says, if a transaction is open in the Management Studio window, then that query window should be color-coded like red, like the house is on fire, so the DBAs can be alert. Mr. JLR is back. I asked him about the fourth candidate that we haven't looked at yet. But Mr. JLR told me the election was to elect 3 candidates out of 4 shortlisted by the nominating committee. The 4th candidate never attended a PAS summit before being pre-selected for the election and thinks PAS is a B2B organization, and B2B organizations like PAS needs fresh thinking, and this is why PAS board of directors selected him for the election. I asked Mr. JLR to show it. Mr. JLR showed me a website where the 4th candidate gave an interview. Meet the PAS board candidate. and a question answer type of information. There the candidate says, we have partnered with PASS, sent a representative to the summit in 2008 and the 2009 event as I will attend, and work with most of the vendors who exhibit there. I am asking for your vote. My platform is diversity and business leadership in B2B organization whose lifeblood is dependent on sponsors, exhibit and online advertising revenues from Microsoft-oriented businesses. Think about why Executive Board of Directors, he means past Executive Board of Directors, put me on the ballot to bring in fresh thinking in a murky climate for B2B organizations like PASS. Here one of the person clarifies, PASS is not a B2B organization. I was under the impression that it was the nominating committee that put you on the slate, not the Executive Board of Directors. Mr. JLR pointed out to a blog in the SQLPass.org website, which was written during July 2009. Last week, PASS voted to update the bylaws by which we govern ourselves. Changing the bylaws requires a 2/3 vote of the Board of Directors. The process starts with a nominating committee headed by immediate PASS President Kevin Klein. Kevin will select committee members. The nominating committee then recommends to the board a slate of candidates for the November election. Mr. JLR pointed out a blog article by immediate PASS President Kevin Klein. What direction do you choose? There, transparency was not a strategic goal of the board or the nominating committee. Vetting the best candidate was the main strategic goal of the nominating committee. Mr. JLR asked me to search for the keyword no democracy without transparency in the site europa.eu. I asked him, what is this site europa.eu? He said this is the official website of the European Union. There you see gateway to the European Union. And there he pointed out, there can be no democracy without transparency. There can be no democracy without transparency. He said these are documents from the European Parliament. Back to the blog. There Mr. JLR pointed out, the board has traditionally not been motivated by transparency coupled with direct collaboration with wider community. Twitter conversations and blog posts with long trailing conversations are a new experience to many with a seat at the board table. While it is important to one or two of the current board members, a transparent and collaborative approach hasn't taken root with everyone on the board. Do you want that to change? Mr. JLR asked me to read the bio of Kevin Klein. There he pointed out Kevin Klein is the technical strategy manager for SQL Server Solutions at this organization. He is also a founding board member and former president of the International Professional Association for SQL Server, PASS. Mr. JLR says, if the founding board member and former president Kevin Klein cannot introduce transparency, then Mr. JLR thinks nobody can enjoy democracy with transparency in PASS. Let's continue with our query. This query is still waiting because of the schema modification lock held by SP recompile. Let's execute tran count. Let's roll back this transaction so there are no more logs held by our session 68, and there you will see this query is not waiting and the query completed. Let's mark the stored procedure for recompilation. We have to find the plan handle and we should supply it to free proc cache. Let's use a quick way. Let's say while 1 equal to 1. Let's execute the store procedure in a loop and let's find out the plan handle. Let's look at the session 66 for the plan handle, and there is the plan handle. Let's cut the plan handle and let's place it on free proc cache. Let's stop the store procedure. Let's execute this dbcc free proc cache with our plan handle, so only this plan will be marked for recompilation. Let's execute it. Now let's execute the query with show plan on. Let's look at the not in a loop, just one time. Let's execute the query with show plan on. Let's look at the hash match operator. There you see estimated number of rows 1, actual number of rows 1. So SQL Server allocated memory to do hash join over this single row. Now let's execute this query, which is going to look at 15 days worth of data. This query will take a long time to complete. Now you can see it's not waiting for a log, and we can look at the status. The query is suspended with sleep task. It is waiting for 10 dB IOs to complete. This plan caching problem can also affect queries that does sort. In the previous webcast, we discussed memory allocation for sorts. We saw how we can increase the estimated number of rows and hence increase the memory by using optimize for hint. For those who have not seen our past webcast, we recommend you to watch them first, as this will give you continuity here.